Our adventure begins deep within the forest, where felled giants await their journey. Here, we see the remarkable dance between man and machine. Massive logs weighing many tons are meticulously loaded onto specialized trucks. It's a delicate, yet powerful operation, demanding immense skill from the operators. Notice how the grapple, an extension of the loader, precisely picks up each log, swinging it with surprising agility before carefully placing it on the trailer. Each log is strategically positioned, ensuring stability and safety for the long haul. This isn't just about brute strength. It's about understanding the mechanics of weight distribution and the art of efficient loading. These trucks, often referred to as log haulers, are custom-built to withstand the rugged terrain and carry these enormous loads, acting as the vital first link in the long chain of timber production. It's a testament to human ingenuity and the sheer power of modern heavy machinery, ensuring that every tree harvested begins its transformation safely and efficiently. In a modern sawmill, the process of turning a tree into usable lumber is nothing short of a mechanical symphony. Fast, powerful, and impressively efficient. Each machine has a purpose, and every step is designed to make the most of nature's most versatile resource: wood. It all starts when a truck loaded with logs arrives at the sawmill. The vehicle is weighed on entry at the scale house. Once the logs are unloaded by a large overhead crane, the empty truck is weighed again. The difference between the two weights gives the exact mass of the logs, a critical figure, as it determines how much the logging crew will be credited for. On average, one full truckload can weigh as much as 26 tons. Once the logs are removed, they're sorted. Some are stacked in the log yard for future use, serving as a buffer during slow delivery periods, while others are moved directly to the log deck, where the journey of transformation truly begins. The first stage is debarking. Logs are fed into large debarker machines that strip the bark clean off using high-speed rollers. The bark doesn't go to waste. Instead, it's collected, loaded into trailers, and transported off-site to be used primarily as industrial fuel. Another example of the sawmill's commitment to reducing waste. Next, the freshly debarked log enters the merchandiser, a highly advanced system that uses laser scanning to generate a three-dimensional model of each log. This scan allows the system to determine the best cutting strategy to extract maximum value. Some logs may be cut down into smaller pieces right away, while others that meet specific size and shape requirements might be designated for use as utility poles. Once cut into sections, logs follow one of two primary routes through the sawmill: the carriage saw or the DLI double-length infeed line. Let's follow the log to the carriage saw first. Here, the log is scanned again using lasers to optimize every cut. A skilled operator sits at the controls and guides the log back and forth along a track, slicing off slabs using a vertical bandsaw. The larger center portion of the log, known as the cant, will be further processed downstream. The outer slabs, which still contain usable material, are passed to the resaw, where thin boards are cut horizontally from the slab. If anything remains that's too thin for boards, it's ground down into wood chips, ensuring nothing is wasted. Unlike most machines in the mill, the resaw is operated manually without the help of laser optimization, a rare holdover from earlier mill practices. Now let's switch to the DLI line, which handles logs differently. After scanning, the log is rotated so its natural bend, or crook, faces downward. It is then processed through the reducer twin, a machine that uses either chip heads or vertical bandsaws to flatten two opposite sides of the log. These flat sides prepare the log, now called a cant, for more accurate cuts in the next step. The cant is then passed to the curve saw gang, one of the most impressive machines in the entire facility. Once again, scanning technology comes into play. The gang saw uses top and bottom arbors, each fitted with 24 circular saws spaced 2 inches apart. These saws follow the natural curve of the wood, extracting the maximum yield possible while preserving structural integrity. This level of adaptation, following the grain and form of each piece, sets modern sawmills apart from older, more rigid systems. boards are rounded based on their shape. Rounded edge boards head to the edger, where they are made square. Scanning systems determine the ideal cut, and automated saws trim the sides, converting imperfect pieces into clean, market-ready boards. Waste material, strips, and fragments is sent to a chipper for conversion into wood chips. Meanwhile, square boards, those that were already edged properly, are sent straight to the trimmer. The trimmer cuts boards to length based on industry standard sizes, typically in 2-foot increments. Each board is scanned, and a movable fence adjusts its position to ensure the most efficient cut. Boards that don't meet quality standards are returned to the edger for another pass. At this point, all acceptable boards, from the edger, resaw, and gang saw, converge at the sorter. This system automatically organizes boards by length, width, and thickness. Once a sufficient number of similar boards accumulates, they're released into a holding bin. An operator then stacks the boards into a pack, ready for drying. The stacker machine lays small wooden spacers, called stickers, between each layer of boards. These stickers are crucial. They create airflow channels so that when the boards are dried in a kiln, heat and air can circulate evenly throughout the pack. Once stacked, a forklift transfers the lumber to the green yard, where it may rest for several days. Here, the wood begins to lose its natural moisture content before heading into large drying kilns. This drying process is essential for preventing warping, shrinking, or splitting once the boards are in use. After kiln drying, the boards may go through a final planing stage, where they are smoothed and cut to precise final dimensions. At this point, they're ready to be wrapped, labeled, and shipped to stores, construction sites, or furniture makers across the country. Once loaded, our logs embark on the next leg of their journey. While many travel by road, some, particularly in regions with abundant waterways, take a more traditional and scenic route, by river. This centuries-old method of transporting timber downstream still finds use in specific regions, especially where rivers naturally guide the logs toward industrial facilities. Operators skillfully roll the logs off the truck beds into the water. Once afloat, these logs become part of large timber rafts, tied together with heavy chains or cables, forming floating islands of wood. These rafts are then steered downstream using tugboats or manual poles. It's a process that blends old techniques with modern logistics. And it's surprisingly efficient, letting gravity and current do the work of hauling hundreds of tons of wood toward the sawmills. As the timber rafts make their way downstream, the river becomes a natural highway. The current does most of the work, carrying the wood slowly but steadily toward the mill. It's quiet, controlled, and requires a sharp eye. In narrower parts of the river, they steer carefully to prevent logs from drifting apart or getting stuck. After several hours, sometimes a full day, the rafts reach the mill's intake area. There, the bundles are broken apart. Cranes lift the logs from the water and move them onto conveyors. From here, the logs enter the first stages of processing. The river has done its job, delivering raw timber efficiently and with minimal fuel or machinery. To truly appreciate the power of modern mills, we take a look back to the steam-powered sawmills of the past. These were the beating heart of early industry, especially across America's growing frontier towns. In those days, massive steam boilers provided the energy needed to power the entire mill. Logs were delivered by oxen, rail, or floated in from rivers. Once on site, they were dragged along metal rollers toward steam-driven saws, enormous spinning blades mounted to wooden platforms. The roar of the steam, the clatter of belts, and the hiss of valves created a soundscape that's hard to forget. Men worked in thick gloves and heavy aprons, moving massive timbers by hand or with hooks and chains. Everything was hot, noisy, and dangerous, yet incredibly productive. The saw blades themselves had to be sharpened constantly, maintained by specialists known as saw filers. Even a small crack in a blade could lead to a deadly failure. So there was a rhythm not just to cutting, but also to repair and readiness. Steam power revolutionized lumber production. It allowed mills to run year-round and in areas far from rivers, no longer dependent solely on water wheels. It also opened the door to more precise cuts, faster output, and greater consistency in timber grading. Despite the dust and grime, there was an elegance to the system. Pulleys and gears crisscrossed the ceiling. Steam lines hissed through the walls, and every worker had a place in the choreography of production. These early mills were the ancestors of today's massive facilities. Though the tools and energy sources have changed, the purpose remains the same: to turn nature's raw material into a product of value, framing houses, building furniture, and fueling growth. Understanding where we came from gives deeper meaning to where we're headed. And what began with steam now moves forward with computers, sensors, and ever smarter machines. We hope you've enjoyed this journey. From the rugged logging trucks to the roaring sawmills of the past and the high-tech factories of today. Don't forget to hit subscribe so you never miss an update. Thanks for watching, and as always, keep building.